take a look at this Go code. Super simple, right? It's just a standard for loop over a string. You'd expect it to just, print out each character one by one, but there's a nasty little trap hiding in there. And when you actually run it, you get this. I mean, G and O come out fine, but look at the check mark. It's totally mangled. So what in the world is going on here? And that's the big question, right? Why does this super common, simple-looking loop just completely fall apart with certain characters? Okay, so the answer is probably the single most important thing you need to get about strings in Go, and it's this. A string isn't a list of characters. Not at all. It's a read-only slice of UTF-8 bytes. So what does that actually mean? Well, look at this. The character G takes up 1 byte. The O takes up 1 byte. But that little checkmark symbol, oh, that's a multi-byte character. It takes up 3 whole bytes. So here's the kicker. When you ask Go for the length of our string, it doesn't say 3. Nope, it says 5. Why? Because it's not counting the characters you see, it's counting the bytes. And that is the trap. When you loop using an index, from 0 to the length of the string, you think you're grabbing 1 character at a time, but you're not. You're grabbing 1 byte at a time. You're literally sawing that 3-byte checkmark into pieces, and that's why you get that garbled mess. So how do we fix this? It's actually super simple. On the left, you see our broken index loop, but on the right, that's the idiomatic Go solution, the for-range loop. Look at that beautiful, clean output. That's because range is smart. It knows how to properly decode the UTF-8 for you. So what's the magic behind range? Well, it's not giving you bytes. It's giving you something called a rune. And a rune, well, you can just think of it as Go's way of saying a single logical character. It's one Unicode code point. It does all that messy byte-level work so you don't have to. Okay, so this all boils down to one simple mental model for handling strings in Go. If you remember this one thing, you'll never run into this bug again. And here it is. It's a simple choice. If you need to work with raw bytes, like you're dealing with network protocols or raw file data, then yeah, use a standard index loop. But if you want to work with the logical characters, the things that we humans actually read, you always use a for-range loop. Period. Seriously, getting this distinction right is going to save you from so many subtle, frustrating bugs down the road. But it does leave us with a cool question, doesn't it? Now that you know the difference, when might you actually need to process a string byte by byte? What are the real-world use cases for that? It's something to think about.